Hi guys, welcome to a new TheLab video from Products with School. Today I'd like to release a first introduction to Ambergan. It is a really nice new software from JangaFX. It is a GPU accelerated volume fluid simulator, and it is still in the beta release. It is around 0.5 release, but actually there is a beta, a public beta, so you can download it. You can go there and you can download. You will have a 14 days free version. Then you will be able to continue using the software, but you will have no possibility to export VDB and some more restriction. So in this case, if you like to continue using the software, you have to pay for it. Pricing policy is not bad. I think it's really nice. You see there you have the possibility to pick Ambergan for $239 for 1 year, and it is really amazing. And here you can see the roadmap. It is really nice what is coming soon. Actually we are here 0.5.0, and then this is what's in progress, and then all the features they are working on. You have a documentation there. There are some information about it. There are some tutorials and the forum and stuff like that. By the way, today I like to make just a really simple introduction to understand, for example, how we can play with the value and parameters we have inside Ambergan, and how we can export in VDB to be used in other software. We'll make some tests using Clarisse and 3ds Max, for example, just to make some preview. So we can close there and we can launch Ambergan. It is loading. Actually on this workstation, okay, the software is there. On this workstation I have an RTX 2070, so it is not a really amazing GPU, but you see that it's working in real time. This is the viewport. Actually I'm using the Alt key with a left mouse button to make the orbit. You see that you have direct access to the emitter, and everything is working in real time to update. We are working inside, you see the voxel grid, so we have something that is playing to give us the sides of the scene, and there you see that we can control in real time everything, and that's really nice. Everything is node based. There with a middle mouse button I'm going to have the pan, and you see that the initial scene is really simple. We have a primitive, and when you select a node you see that you have there inside the node info everything about this node, and here you see that we have some preferences about the node. There is the type. Obviously you can also animate and do stuff like that. By the way, today I like just to play with the scene and then export the data. Here you have different shape. So for example we can decide to have let's say a torus. So you see that in real time we have an update. You see that there we have the volume that is bringing inside the simulation, and you have the possibility to change the position, the rotation. So for example we can decide to rotate over the x-axis. So let's start to rotate, and you see that it's working in real time without problem. Okay, that's really nice. So we can revert to the default value. This parameter there, we can open the timeline, so we can play with this parameter. We can play with it without any problem. We can, for example, say to have maybe there that we have more space, and So let's do something. If you press the space bar, you will have to stop. So you see we can stop the playing and we can have again the playing in real time. So you can do it in many ways. And something I like to do is to move the data from the rotation here inside the timeline. You see that there you have the possibility to click over it, and you see that you have no override, timeline override, and not graph override. If you press one time, you see that now you have the parameters there. So you have the timeline and you have the value you like to play with. So in this way you can play with the animation without problems. So for example, we can go, let's say, at a frame, it's going away. Let's say that we go at a frame, let's say around maybe 20, right mouse button. So let's say that, for example, there, with the right mouse button, you see that we have the possibility to choose to delete a key or to add a key. Let's say that we add a key to the rotation. So you see that's the animation. Let's say that we have, let's do the pan. So we go to the beginning, we have 0 to rotation, around 0, and then we have a rotation of 60 at frame maybe 40, let's say right mouse button over the key, and then let's say, for example, 60 degree. And if we go to see the simulation now, we can say to restart the simulation, press space bar, and you see that we have this kind of animation. Okay, let's stop. Let's say that then, for example, at frame maybe 100, right mouse button, rotation X, and let's say that we go back to a lower rotation, so just a rotation back and forth. So let's close this one, press R. With the R key you are resetting the simulation, then space bar, and you see that we have the first rotation and then it is back. Okay, space bar. So then you see that here we have all the information about the primitive that is emitting. So that's the emitter, and actually we have the input for the shape, and we have no forces actually. So we have the primitives, you know, you can change everything about the simulation, it's not a problem. We will see in the future everything about it. So actually I like just to play a little bit with other stuff. So you see that then you have the simulation. The simulation is nice because, let's say, to show the bounce. That's the scale of the voxel where we are inside, and how we are playing inside this scene. So let's go to change. You see there we have higher voxel count. So let's say that we have 228 over this axis. Let's say that we have more voxel in both axes, and then apply new resolution. You see that it's bigger. So press R and then space, and you see that now it's bigger than before. With the right mouse button we can make the orbit, and you see that there we have the possibility to have a bigger simulation. By the way, maybe it's too big, so let's say that this one is maybe 180 and 180, and then apply resolution. Press space, and you see that now maybe the spacing is better. You know, you have to take care about the spacing, because it can be a problem if you have obviously a really big scale, because you are losing memory and speed to generate voxel in an area where we don't need it. Okay, let's say that we changed the scale, and that's nice. If you like, you have a really nice possibility to upscale the simulation, because you know there you have the voxel size, so you can say, for example, that the voxel is a little bit more little. So we go to simulate, and we'll have a nicer looked simulation. Obviously, simulation is also more complex to simulate. By the way, it's not a problem. So we can see the differences if I go there and let's say 0.5, and then we go back with the R and then space bar. We are changing the scale of the simulation. So something interesting is that obviously the dynamic is changing because we are scaling the size of the voxel. By the way, what I like to do is to show you that we have, obviously you see that everything is changing about the scale. By the way, the nice thing is that we can upscale this simulation. And what I mean, actually it is using, you know, it is around 20 meters by 20 meters by 30 meters, and we are talking about this amount of voxel. So it's not so complex. If we go lower, let's say 0.5, you see that the scaling is changing, so it is more little. Okay, so that's something you have to take care about the dynamics. By the way, we can change the quality going to the upscale. You see that there we have parameters. By the way, let's set to off. Let's set to the new resolution, and there we have the upscaling. And here you can add more resolution. So we are going to upscale the value we set there. So if we press space, we'll have a higher quality because we'll have more details over the simulation. If we go higher with this value, let's say, for example, we say 4 and apply. Okay, and press space. It was faster to be simulated. You see that actually it's going slower than before. It is going around 3 frames per second or stuff like that. So it's really slower than before because the quality of the voxel is higher. So it is more complex to be simulated, and that's why it is going to be slower than before. It can seem really slow, but you have to imagine that with CPU it will take really more time to be simulated. So let's stop, and I like to go a little bit lower with the upscaling and apply. And inside the simulation, obviously, you have some information about, you know, the combustion, the decay, you have the dissipation, you have the vorticity. So maybe we can go back to no upscaling, and then we can go to see, for example, what happens if we have an higher vorticity. So let's say that the intensity of the vortex is 75%, press space, and you see that we have an higher vorticity than before. Okay, so we are going to simulate more vortex, and let's go maybe to 50. We can play, and then you see that there we have the intensity for the larger vortex. So let's say that maybe we have 75% for the bigger one. So let's press R. You see that we have more chaos than before because we have bigger and larger vorticity. Let's go for the lower one. Oh, sorry, let's go back to 25 and R. And you see that it is really nice because we have 2 layers of vorticity. There we have all the information about the forces, so we have really nice information about the cooling, and about the dissipation. So for example, we can say 0.1. You see that it's really fast. We can say, for example, 2, and the smoke will go higher because it takes more time to be removed from the simulation. Okay, maybe we can say 1.5. And about the vorticity, let's go a little bit lower. Press R, and we have again the simulation from the beginning. So it's a mixture between the first one and the lower one. We have the flame dissipation rate. It is the same. So if we say, for example, 10, let's press R. The flame dissipation is different than before, so it is rising up more. Let's try to add still more. Let's say 20. Okay, and let's say that also the fuel needs a little bit more time. And press R. So we should have 5 for more time inside the simulation. So, by the way, that's really simple to tweak, and we'll play with this in some more videos. By the way, let's go back there, and let's say that we have the upscaling to 2, and apply. And you see that it's going slower than before, but it is really nice. And if needed, we can rise up more to have a really high quality simulation. So let's say that this one is good for us. You see that then after the simulation, you have the volume to control the rendering, you have the light to leave the scene there inside this viewport, and then you have the information about the scene, you see about the rendering, and then you have the capture to capture the rendering if you like to save the images out of Ambergan, and you have the camera. By the way, we need something to export the simulation, and to do something like that, we can stop the simulation. Right mouse button over the node graph, and you see that here you have all the features that you can use. Actually, you have export, and we go for VDB. You go to connect the simulation to the input, and this node has the file name. We can choose where we like to export the data, and I say that here we get to have test export, and let's call it explosion. Okay, it is going to export the frame from 0 to 64. Let's say that we go higher, let's say maybe 150 frames, and it is going step by step by 1, so from 0 to 150, and it's going to use 1 frame by 1 frame. It is going to export the density. I like to export also the temperature, and we are going to export the flames. If you need to play with a motion blur, we can export the velocity. By the way, actually I don't need it because I'm going to do something really simple. Some information that are really useful is the coordinate system, because you know it is going to rotate the VDB in the right way. Actually, it is set to Z up, so it's the same as in 3ds Max. So the Z-axis is the up axis, and you know that in other software we have the Y-axis. And then the right-handed, it means that the X-axis is over the right. If you press, you have the possibility to change as you prefer, so you can export in the way you prefer for your software, or you can change later in the software, because you can rotate the VDB object you just imported. Let's say that we leave with the default value, and then we have just to press over the export now, and it's going to simulate. You see, frame by frame, it's going to export the simulation. It takes a little bit of time, obviously. It's going to go at the speed we saw before, but you have to think about that it is also writing the cache over the HD, so it needs a little bit more time. We can go to see how it is going, and you see that it's exporting each frames step by step. Okay, so cache can be big, so it is nice if you can use a really fast cache disk, for example an SSD. So let's wait for the export, and then we play inside Clarisse, inside 3ds Max, to see how it looks. Okay, you see the quality is really nice. It is done, so we can set to off, and we can load, for example, Clarisse. We can make a first test inside Clarisse, and then we try to load the same data inside 3ds Max. So let's close Ambergan. It's okay, I don't want to save, it's really simple. Or maybe we can wait to have the simulation done. So I'm not going to create context, complex context. So let's just create one, and let's say VDB. I go to use this context for the viewport, and I say I go to load a new geometry, a volume file. Let's say that this one is the Ambergan loader. Then we go to choose the file, and we have just to pick the first one. So Ambergan, Ambergan test export, the first one, save to open. We have 150 frames. Let's go, for example, as frame 30. We have to say to detect the sequence. If it is not able to detect automatically, we can say to use until the frame 49. So I think there is something that is happening, you see. So let's say that this one is the camera we're going to use for rendering, and let's zoom back. The scale is really big actually. If you like, you can obviously scale it down, let's say to 10 times. So we can manage this one as a normal, as a standard mesh. You see that Clarisse is using the y-axis, and it was exported using the z-axis. So we need to rotate the object. By the way, I go to close this one. Okay. So we have the simulation that needs to be just rotated, so we can rotate over the x-axis. So let's say 90. Okay, we have it in the right way. Let's go forward. It's the wrong, so it was minus 90. Let's see if now it's the right one. Okay, we can move it. It's not a problem to move it. So let's go forward. You see that we have everything. So some information about the rendering. Actually, it's using the density channel. Here we can decide if you like to use the density or the flames or the temperature. Then if we exported the velocity, we can say which channel needs to be used as velocity, but we will work on something like that in the future. Let's go to select the render image, and that's the render image. Let's say that we go to 100%. So we need, let's go faster. We need a material, so we go for material, volume. We can assign this one. You see that it's working in a different way. Physicist, so now it's playing with the right simulation. We can say that we like to have a less dense color there. Let's say that we have a new context, and this one is the textures. Because we have to say to this shader to use the black body for the fire. So in the emission, let's press, and inside the texture, right mouse button, new texture, black body, and select this one and say apply. Okay, it needs to be tweaked, so let's go there, select this one, and we have to play with the temperature. So we can choose to create a new texture, utility, extract property. So let's say that we use this one, and the extract property name, and say to use the temperature. Okay, so back to the black body, and if we like, we can scale down. You see the temperature to have something that is more similar to what we done before. And again, back, if we go there, we can pick the volume and say that we like to have a denser smoke, okay? Or we can go lower, it's not a problem, and we can decide how to render this one. Simulation can be simulated obviously with an higher quality, and back in the texture, let's go in the black body, and here you see that we can play with the temperature as we prefer. We have the offset of the temperature, so we can create some really nice looking shading and material about it. Obviously the resolution can be still higher. By the way, we have some ways to control also the density using some texture and stuff like that. So you see that essentially we have the simulation that is working perfectly inside Clarisse, and also in a really fast way. Okay guys, that's all, and the video is coming to be really long, so I prefer to split in more parts. In the future we'll prepare some more tutorials about EmberGen, talking about importing the VDB in other software like 3ds Max, Houdini and stuff like that, and we'll move forward to create some really nice simulation in higher quality. So thanks for watching, and we'll talk more about EmberGen and other software really soon. Bye bye.